I hate typos. When other people make them, at least. So I combine the forces of modern, well, less than a decade old at least, machine learning, and GoFi to put them to rest, and create the ultimate keyboard. Backstory, or why I embarked upon this mess. One day, when I was browsing Reddit, as those who have succumbed to social media addiction are wont to do, I came across a common typo that completely changed the meaning of a sentence. The actual typo was so insignificant that I can't even remember what exactly it was, so I'll sub it out for an isomorphic example. Suppose I were to tell you that it's probably a bad idea to kill the Archduke Franz Ferdinand. That sentence is entirely different in meaning to, it's provably a bad idea to kill the Archduke Franz Ferdinand. I don't know what it was about the typo I saw that day. It was certainly of less historical importance than what I outlined above. But the pure psychic damage I took seeing that typo on Reddit made me snap. And I spent the rest of that night coding an algorithm to find the perfect keyboard. The algorithm. To create the optimal keyboard, we first have to decide what we're going to optimize over. The most important factors in my mind are A. The semantic significance of a typo. How much the typo changes a sentence's meaning. There's not much use creating a keyboard that stops you from swapping the Z with an S in unionize, since all that typo does is make you seem slightly more Australian. Sorry, Australia. I'm with the Americans on this one. Z's just look better. Instead, we should be trying to stop typos like red to bed. Having red hair and bed hair are entirely different things. So we should be focusing on typos like that and not the less significant ones. 2. I don't care about typos that result in a fake word. For example, apple to April. Spell check will pick up on that anyway. We have better tools for the job than designing an entire bloody keyboard around it. C. I'm only going to consider one-letter typos in my algorithm. I could come up with a faux mathematical explanation for this. Independently and identically distributed typos, in the probability changes with p to the power of the number of typos in a word. But realistically speaking, it's just a pain in the ass to model. And this was more of a hobby project than a serious attempt at designing a keyboard. People have already done that, and probably better than I'm going to. So in sum total, what we want is a keyboard that minimizes the probability and semantic impact of one-letter typos. How do we go about designing that? We'll start by tackling point 1, semantic significance. To the naive computer scientist, this might seem like a bit of a hard problem. How can a computer know what a word really means? But to the even more naive data scientist, it has a simple answer: vector word embeddings. Back in the dark ages of 2013, an engineer at Google figured out a simple trick. By doing a bunch of machine learning alchemy that's way out of the scope of this video, you could embed words in something called a vector space. And if you mix around the pot of linear algebra just right, don't forget to add I of Newton, then words close to each other in meaning will be close to each other in this space. By downloading a pre-computed word embedding and a list of word frequencies I found online, I can find the significance of each individual typo and weight them by the probability of them occurring, equal to the average frequency of each word in the typo multiplied by their distance from each other in the word embedding. Call this a word pair's typo score. Then to find the total impact of a letter substitution, we can sum the score of all typos that mix up those two letters. Now that we have a score for each letter substitution, we need to build it into a way of scoring whole keyboards. To do this, we can model the probability of a letter substitution occurring on a given keyboard, then take the sum of the probability of all letter substitutions multiplied by their score. For this project, I decided that the probability of a letter substitution should be proportional to the inverse distance between keys. The further away two keys are, the less likely you should be to make that typo. Since I have formal training in operations research, and to me every problem is just a linear equation waiting to be solved, I took out my favourite hammer, mixed integer linear programming. Mixed integer linear programming? For those not in the know, mixed integer linear programming is a way of solving optimization problems that you can phrase entirely in terms of integer variables and linear constraints. For example, the key variables in our problem are the placements of our keys. For example, is the letter A on the top left of our keyboard. Thankfully, these can be expressed entirely in terms of a large set of Boolean, and therefore integer, variables. Similarly, we can also express our constraints, no two keys share the same position, and our goal, minimize the impact of an average typo, linearly. If this video gets enough engagement from massive nerds like me, I'll release a follow-up vid with more specifics on my encoding. The major advantage of all this faff about linear programming is that it enables me to be profoundly lazy, one of my few major strengths. Once we describe our problem, our solver, SIP in this case, I'm not bougie enough for a Gurobi license, will do the rest for us. Actually programming it. Most of the programming for this was a breeze. I chose a word frequency dataset and a word embedding, both outlined in the GitHub project, and hacked away the first part in a night. Then I hit the MIP. I could have sworn my model was correct, but every single time I ran it, I was getting the same keyboard. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. It was the alphabet arranged from left to right, up to down. That's not the correct bloody keyboard, unless something profoundly unlikely is happening. After a wild search, I eventually found the culprit, a rogue line of code in the middle of my script. Hashtag sanity check. Solver.maximize 0. I was optimizing the number 0. It was finding the first feasible solution, which was just the entire alphabet in order. After a bit more bug fixing and a thorough smack on the back of my head, I cleaned it up and ran again. To no particular avail. After over 5 hours of searching, SIP was unable to find an optimal solution. On the bright side, it was able to find tons of feasible solutions along the way, if only I could access some of those. Turns out, the library I was using, Google OR Tools, doesn't give you a great way of doing this. So I did a dirty hack and turned my optimization variable, minimize typo scores, into a constraint. Give me a result with typo score below X, then ran it with X a bit above the best feasible solution found earlier. That didn't work, so I relaxed it a bit more and eventually got a feasible solution, albeit, a bit shittier of one than I would have hoped. The optimal keyboard. Without further ado, the best keyboard I was able to find was EIDPVHKRXA WSBZJYLMC NFGUTQO. Moving V a total of 1 key further away from B. All this effort for nothing. Future work. There's clearly a lot of room for improvement here. Solving the problem as a genetic program, or maybe with simulated annealing, might uncover better solutions, since I wasn't able to run my MILP to optimality anyway. To be honest, a better MILP encoding might do the trick, or even a better solver. I have a few ideas in mind, but I was pretty sick of the side project by the time I found that silly maximize 0 bug. You could try including other types of typos. Insertions and deletions in particular are promising, and there's a simple algorithm, Levenshtein distance, for computing how likely a typo should be. Permutations seem a bit harder to deal with, perhaps a problem for the further future. Like and subscribe! Remember to like and subscribe. If enough people are interested, I'll do a follow-up on some fun data that I found while working on this project. And join me next time for a video on Bris Vegas's public transport system.